So hello dear students, welcome to today's lecture. So again today we will see another theorem. Okay. So the theorem says that given one integrating factor of the Pfaffian differential equation x1 dx1 plus x2 dx2 plus etc. xn dxn equal to 0, we can find an infinity of them. So the theorem says if you can find one integrating factor for a given Pfaffian differential equation, then you can find infinity of them. So the proof goes this way. So we will start with an integrating factor. So you are given one integrating factor of the Pfaffian differential equation involving the n variables x1, x2, etc. xn. So mu of x1, x2, etc. xn is an integrating factor. In integrating factor anengil, there will exist a phi such that mu xi will be equal to dou phi by dou xi. അപ്പോൾ mu കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്തതിന് ശേഷം ഈ ഇക്വേഷനെ എനിക്ക് ഈക്വൽ ടു ഡി ഫൈ എന്ന് എഴുതാൻ പറ്റും. സോ mu xi will be equal to dou phi by dou xi for I equal to 1 to etc. n. So that is by the definition of integrability. അപ്പോൾ integrating factor വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യുക, മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ that component will be in the form dou phi by dou xy. Now you have this function phi here, and now let me take an arbitrary function of phi, any arbitrary function of phi, and I'll call it as I of phi. So I of phi is an arbitrary function of phi, and I am going to write the Pfaffian differential equation in the form mu dxi by d phi into x1 dx1 plus x2 dx2 plus etc. xn dxn. Now let me multiply mu inside. So mu x1 you will get mu x2 etc. mu xn, but each mu xi is equal to dou phi by dou xi. So what you get here is dxi by d phi into dou phi by dou x1 into dx1, dou phi by dou x2 into dx2 plus etc. dou phi by dou xn into dxn is equal to 0. Now you multiply dxi by d phi into this equation. So in the first term you are going to get dxi by d phi into dou phi by dou x1. So by chain rule you can see that it is equal to dou xi by dou x1. Okay. Then dou xi by, so this equation you multiply dxi by d phi inside to each term. So by chain rule that is going to become dou xi by dou x1 into dx1, dou xi by dou x2 into dx2 plus etc. dou xi by dou xn into dxn. Now this is in the form of an exact differential, so that is equal to dxi equal to 0. So xi, so dxi equal to 0 means xi of phi, okay, this is equal to c. It's not 0, the xi of phi is equal to a constant. So that is the solution of your given Pfaffian differential equation. So thus if mu is an integrating factor and corresponding to mu, so if you are getting the solution phi of phi equal to c, so what happens is if I am taking any arbitrary function psi of phi, okay, so if I multiply this function to the given Pfaffian differential equation, so you are going to get a solution here. So that means mu into dou xi by dou phi is also an integrating factor. Now here you know xi is an arbitrary function. So since xi is an arbitrary function, you can have infinitely many functions mu dxi by d phi. So there can be infinitely many integrating factors provided one integrating factor exists. So that is the theorem. So if one integrating factor exists, or given one integrating factor, you can find infinitely many integrating factors.